Hey guys, we are starting chapter 8 today. And we are going to be in the very first topic of our unit, which is 8.1. And the essential question today is, how can I graph a quadratic equation? So this is kind of fun. We've been learning about quadratics. We know what the term means. But today and throughout this unit, we're going to be working on how do we graph quadratics and what do they look like. And eventually, we basically, as algebra students, want to become experts at this. This is going to be kind of our thing. So, main idea today, quadratic, that word. What do we remember? Well, anything with an x squared. Well, not anything, I should be careful how I say that. But when the highest power is x squared, we call that a quadratic, x squared. And there's a parent graph, which is, remember we've talked about families of graphing before. One of the families we've been learning a lot about this year is linear graphing. Linear, it means lines. And the parent graph is always the most basic graph of that family. So for linear, it's y equals x. A very easy straight line. But for quadratic, it is y equals x squared, and that's the parent graph. So what we're going to do for our notes today is we're actually going to graph the parent graph and take a look at it. And the easiest way to graph these is to probably just build a table, to be honest. Put some numbers in and see what you get. Do a little number crunching. So I'm going to go with my standard typical numbers. I like to pick from -2 to +2. So I have a couple negatives, I've got a couple positives, and I got 0 in the middle. So those are my numbers I'm going to be putting in my table today. -2 to +2. All right, so how are we going to do this? Well, the equation is y equals x squared. So if it's -2, we're going to do -2 squared. A -2 times a -2, which is a +4. If it's -1, we're going to square it. -1 squared is -1 times -1, which is a +1. 0 squared will be easy. 0 times 0 is 0. 1 squared is 1 times 1. 2 squared is 2 times 2, and that's 4. So we've got our values, and we're going to plot these as points on our graph to see what it looks like. And I'll make a little space here so we can graph. So be sure you have a ruler and set up a nice, neat XY axis. Make it neat and organized. Be sure you're doing what you do with linear graphs, where you're putting on a scale and making sure it's even and all that good stuff. And what I'm going to do is basically plot these points. So starting with the -2 and the 4, the first numbers in the table. I went to -2 and up to 4, and I'm putting a dot. Then the next one's at -1, 1. So I'm going to go to -1, 1, place a point. 0, 0 is right in the middle. That'll be easy. And then I have +1, 1. And +2, 4, and those are my points. And you'll notice the graph kind of does this thing where it goes down and then goes back up. Well, this is what all quadratics look like. They make this smooth U-shaped curve that kind of goes down and around and wraps back up. I do not use a ruler to connect this. Don't do this thing where you start connecting points with your ruler, like connect the dots almost. You don't want this to look jagged or sharp. You want it to look very, very smooth. The idea of a quadratic graph is it's all very smooth curve. There's no ruler connecting the points, basically. Which for some of you that love to get out that ruler and make everything straight and perfect, you're going to have to freehand this a little bit to give it that smoothness. So just kind of saying there. Now, what is the name of this graph? Well, we have a special name for it. We call it a parabola graph. It's a quadratic, but the fancy name for that smooth curve is it's called a parabola. And it looks like parabola, but don't call it parabola. That sounds weird. It sounds like a disease or something. It's parabola. And so here are the key characteristics of a parabola graph. We're going to kind of list these out. So first off, it's nonlinear. We're not talking about lines. We're talking about the smooth curve. So it definitely falls into a nonlinear category. It'll look like this, which I'm just going to kind of free sketch one, or it'll look like this. It can point up or it can point down depending on the equation. So that's kind of a key characteristic, either points up or points down. Another key characteristic is, let's list these out, main characteristics. So there's basically 3 of them. So when I'm talking about these key characteristics, I'm really narrowing it down to 3 things. The first thing, number 1, is there's what we call symmetry. Symmetry is when you can fold something in half and the left and right look the same. You ever, in Valentine's Day, like in elementary school, did you guys ever cut out hearts where you would like fold it and cut out one side and open it up and it'd be the whole heart? That's symmetry. I always say in class that the human body is full of symmetry. Our left side looks like our right side. Maybe not perfectly, maybe you have a scar on the left and not on the right, or a freckle that's a little bit different, But generally speaking, our ears look the same on the left and right, our eyes look the same. If they didn't, that would be a little bit strange. Our arms are usually the same length on the left and the right, same with our legs. So that's symmetry. It's when you can fold something in half, and I call it the fold line. So like on our picture here that we drew a minute ago, I could draw a dotted line down the middle and you could fold it over on itself. Or I could draw a dotted line down the other one, and there's the fold line. And the fancy name for the fold line is we call it the line of symmetry. So you should write this down in your notebook, line of symmetry. Okay, so that's one main characteristic, is the parabola has symmetry, has this fold line. Second characteristic is they always have what's called a vertex. And a vertex is the highest or lowest point on the parabola. So there's always a really high point or a really low point. And if you go back to our pictures, here's where the vertex would be, at the bottom of the parabola or at the top of the parabola. That's the lowest or the highest point. And I'm just going to label that vertex. All parabolas have a vertex. All parabolas have a line of symmetry. You will find them every single time. So what's the third characteristic? Well, the third is quadratics can be written in what we call a standard form. So the equation is always going to look something like this. ax squared plus bx plus c. Oh, I got a typo there. I got to fix that. bx. That looks weird. ax squared plus bx plus c. There we go. So ax squared plus bx plus c is the standard form. The a, the b, the c are actually numbers. They're not actually variables. So it could be things like 3x squared plus 5x minus 10, or 2x squared plus 7x plus 4. A, B, C are just numbers, but that's the standard form of a quadratic, and every time you graph it, you get a parabola graph. All right, so where in the world do we find parabolas? Because we've established lines everywhere. I mean, we spent a lot of time on linear lines. But check this out. Do you see the parabola in this picture? It's the Eiffel Tower. Of course you see the parabola. It's right there in the bottom of the Eiffel Tower. Absolutely. How about this one? Where's the location and where's the parabola? Yeah, it's San Francisco, Golden Gate Bridge. So there it is right there. See the parabola? Okay. You already know what this is. Where's the parabola? There's actually kind of two parabolas. You count the first arch and the second arch as a parabola. You will never look at McDonald's the same. Now you will only see quadratic graphs. A location you should know locally, our bridge. Okay, so look, there's our parabola. A lot of structures that have been built have quadratic curves to them, like the bridge here. How about this place? Doesn't this look nice? Wouldn't it be really great to be there right now? I hope you're watching this video lesson on a beach right now. That would be awesome. There's our parabola. How about this one? There it is. Drinking fountain. Oh, this is cool. Double rainbow. Not just a regular rainbow, but definitely a parabola here. You can see the double rainbow in the background. So, another one. Parabola. Where is it? Boom. There it is. I can make up millions of these. You can find a parabola in any curved shape now. So now when you look at things with a curve, I hope you're thinking, oh, it looks like a quadratic curve. Maybe you are, maybe you aren't. So, oh yeah, this is the last one I don't want to flash by. So we're going to try an example now, and we're going to practice a problem. And I think I'm going to switch screens so I can handwrite this out with you. But we're going to practice graphing some of these quadratics. So let's give it a shot. All right, so I am switching to paper and pencil now. And I definitely need a ruler for this example. And we're going to put our first problem here. And basically, here are our directions. We are going to graph y equals x squared minus 4x plus 4. And we're going to go through this in a few different steps. So first off, I totally know it's a quadratic. It's got an x squared. I'm like, okay, I'm expecting a parabola graph. But what are some things I can label and kind of notice in this problem? Well, one thing is I can label my ABCs for my standard form. Remember, standard form is ax squared plus bx plus c. So notice what my ABCs are. Now my c looks like it's equal to 4. My b looks like a minus 4. And what would a be in this problem? Well, a would be the number 1 that we don't see. So a is equal to 1. So there's my ABCs, 1, -4, and 4. And let me show you how that's going to be helpful in graphing. We are going to graph in a couple of steps, and here is step 1. So I'm going to write that right here. Step 1. The first step is it's nice to find where the vertex and line of symmetry are going to go. So I'm going to write vertex. And we have a little bit of a shortcut to doing this. A lot of it's just kind of memorizing. We have a formula that helps us find where the line of symmetry goes. And it looks like this. X equals negative b over 2a. Now, I don't really know what else to tell you other than if you memorize it, it's the easiest way to go. X equals negative b over 2a means if you use the b and the a, you can use this formula to find the vertex. So in our problem, b was negative 4, so I'm going to rewrite this here. Let's see, this is x equals negative blank over 2 times blank. So where the b was, I'm going to be putting a negative 4. And where the a was, I'll be putting a 1. So it'll look like that. Now on top I have a negative 4, so that actually is a positive 4. And 2 times 1 is 2. So I have 4 over 2, and 4 divided by 2 is just 2. So our line of symmetry is happening at x equals 2. X equals 2. And that's really going to help me out when I go to start graphing. In fact, I'm going to start setting up my graph now, so I'm kind of ready to go. So over here, where I have some room, I'm going to draw my y-axis, just like so. I'm going to draw my x-axis, like so, and probably get a nice little scale on here real fast, so I'm at least a little bit set up for how we want to do this. Now, we just found that our line of symmetries happen at x equals 2. So here's x equals 1, 2, 3, 4, and 5 for my numbers. Put some numbers on here. And pause the video if I do this too quick for you. Sometimes I just fly through this. Okay, so what did we just find out that's really important to us? Well, we just found out that x equals 2 is the line of symmetry. So here's 2. Here's x equals 2. And what I'm going to do to help myself is I'm going to draw my dotted line of symmetry because I already know that that's where the graph will fold in half. That's what I just figured out in my first step 1. So I'm going to write line of symmetry. Just like that. Line of symmetry. Okay, so that's step 1. Let's move on to step 2. Here is step 2. Step 2. We're going to build a table. We're going to find some table numbers and values that are going to help us figure out how to do this graph. So I'm going to be kind of smart about how I set up my table. I'm going to think this through a little bit. Normally I tell you I like to do -2 to +2, right? And that's usually the truth. But on my graph, if I do -2 to +2, I'm going to be graphing all of this section right here from -2 to +2. Well, what about all of this? I kind of think I need to stick close to my fold line, my line of symmetry. So I'm going to be a little more strategic in my table. When I set up my XY table, watch what I'm going to do. The number that should be in the middle of my table should be the middle where my line of symmetry is. So the number 2 is really what should be in the middle of my table. So I'll back up and do 1 and 0, and I'll go forward and do 3 and 4. And those will be the numbers that I crunch in my equation. Remember, the equation is y equals x squared minus 4x plus 4. So that's what I'm going to be using. But I'm sticking close to my line of symmetry, which is happening right there at 2. So I'm going to do 0. 0 is going to be nice and easy, actually. Let's see, 0 squared minus 4 times 0 plus 4. That's just 0, 0, and plus 4, so 4. So that's not bad. So we got, first point on the graph is at 0, 4. The second point is going to happen at 1, so we're going to have 1 squared minus 4 times 1 plus 4. Let's see, 1 times 1 is 1. Minus 4 times 1, so minus 4 would be -3 plus 4. -3 plus 4 is 1. Okay, let's do the 2. So it'd be 2 squared minus 4 times 2 plus 4. 2 squared is 4. 4 times 2 is 8. So we have 4 take away 8. That's a -4. Plus 4 is 0. Did you follow me on that? Now I'm going to do 3. 3 squared minus 4 times 3 plus 4. 3 squared is 9. 4 times 3 is 12. So right here I have 9 take away 12 plus 4. 9 take away 12 is a negative 3. Plus 4 would be a positive 1. And then the last one, I'm going to do 4 squared minus 4 times 4 plus 4. Oh my gosh, that's a lot of 4s. 4 squared is 16, and 4 times 4 is 16. So I have 16 take away 16 plus 4. That'd be 0 plus 4, so I get 4. And I'm done. I've got my table. Now notice, I'm going to go draw my lines in my table. I really hope something is standing out to you right now. And that is, the line of symmetry is at x equals 2 right here in my table. Look at the numbers as they work their way out. 1, 1, 4, 4. The next numbers I bet are going to match each other. Because it's symmetry, they have to match on the left and the right. So this is going to make a lot of sense on my graph when I go to plot my points. I'm going to start with 0 and 4. So I go to 0, I go up to 4, and make a dot. I'm going to go to 1, 1. 1, 1. I'm going to go to 2, 0. 2 zeros right on the axis. 3, 1. 3, 1. 4, 4. 4, 4. And sure enough, it looks like that parabola shape. I mean, it really does. So I'm going to connect my points now. Kind of like this. And this. And there it is. There's my smooth parabola curve. And what I'm going to do is I'm going to label vertex, which is happening right here. And I've got my line of symmetry. And then the last but not least, something I don't want to forget, I'm going to write it a little bit smaller, is let's put the equation next to one of the arrows. So maybe this one, I'll write y equals x squared minus 4x plus 4. And there it is. We've got our graph. And generally speaking, those are the 2 steps to graphing a good parabola. It's find the vertex, build yourself a table, and plot the points. So let's try another one of these and see if it's really making sense for you. All right, let's do an example 2 now. And for example 2, we're going to graph a different equation. So we are going to graph y equals negative x squared plus 3. Now we know our steps. We have now practiced one of these. So we know step 1 is going to be find the vertex. So that'll be step 1, which I'll write right here. When we're done finding the vertex, we'll move to step 2, and step 2 will be building a table. So step 2 is building a table. And that's really going to be my 2 main steps. Before I can kind of jump into my work here, I want to remember that for the vertex, I need to know my ABCs. So I need to know what's this quadratic equation doing. And my standard form is ax squared plus bx plus c. So this one's a little tricky because I see the ax squared and I see the plus c. There's actually no bx. There's no x in the middle of this one. So b in this problem is actually equal to 0. It's kind of missing. C is going to be equal to 3, but what's a going to equal? Well, there's not really a number here, but there is. Negative x squared is like a negative 1 is what it really is. So a is equal to negative 1. And that's going to be my ABCs. So we have negative 1, 0, and 3. And that's going to help me find my vertex because for my vertex formula, I have to memorize it's x equals negative b over 2a, which means it's really negative blank over 2 times blank. So we got to fill in those blanks. So what's b in this problem? B is 0. What's a? It's negative 1. So I know on bottom I get 2 times negative 1 is a negative 2, but a negative 0 is just 0. And what's 0 divided by anything? 0. So our vertex is happening at 0. So we've kind of got that now established. So why don't we, before we build our table, why don't we start setting up our graph a little bit here? And that's, I think, the next best step. So let's see, I'm going to put a y-axis over here, something like this. I'm going to put my x-axis just through the middle somewhere, like here. And real quick, just put on a scale. It's just easier to get all these numbers on here ahead of time. There we go. I'll label it with some numbers too. So let's see, this is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, 6, 7, 8. I just want to make sure everything's kind of set up in advance. So if I was fast, just pause the video. You guys know that. All right, so what do we know? Well, we know where the vertex, the line of symmetry, is happening. It's happening at 0. So that makes this one kind of complicated because my dotted line is happening at x equals 0. So the actual dotted line is landing on the axis through the 0, which I kind of have to make look like this. Line of symmetry. So knowing where the line of symmetry is, now I can set up the table and know kind of what I'm doing. So my table is going to have my x, y values. And this time, my negative 2 to positive 2 makes total sense because 0 is in the middle. Remember, your symmetry goes in the middle. So if 0 is in the middle, then yeah, negative 1 and negative 2 and positive 1 and positive 2 kind of sandwich that. Now my equation is y equals negative x squared plus 3. So I kind of have to work with those numbers. I think this might be a little more confusing. Negative x squared means it's negative blank squared plus 3. And what's going to go in my first table value is a negative 2. So watch this. This is complicated. So I have negative 2 squared with an extra negative on the outside. Pretend this negative's not there. What's a negative 2 squared? A negative 2 times a negative 2 is a positive 4. But with this thing, it turns back into a negative 4 plus 3. And negative 4 plus 3 is a negative 1. So there's our first number, negative 1. Now I'm going to do the next one. So it's negative x squared. So let's see, I'll draw a line here. Negative x squared, so blank squared plus 3. This time I'm going to be filling it in with a negative 1. So there's kind of a lot of negatives again. I'll ignore the outside one. Negative 1 squared is a negative times a negative. It's positive 1. But then with this minus sign, it turns back into a negative 1 plus 3. And negative 1 plus 3 is 2. So we get equals 2 for our next value. And then for 0, a little easier with the 0, it'd be negative 0 squared plus 3. But 0 squared is just 0, so it's going to equal 3. Now, remember, as we were setting up our table and doing our numbers, 0 is where our symmetry is, so I'm expecting some reflections here. I bet you the next number is going to be a 2, and then the next number is going to be a negative 1. But I'm going to verify that just to make sure my math is right. So for this one, negative x squared, negative blank squared plus 3, I'll be putting a 1 in there. Now think about it. Ignoring this one, what's 1 squared? 1 times 1 is 1. But with the negative, it'll be a negative 1 plus 3. And negative 1 plus 3 equals 2. Exactly what we guessed it would be. And of course it's 2 because it has to match this one up here. So the next one's going to be negative 1. It'll be negative blank squared plus 3. We're going to put a 2 in there. 2 squared is 4. But it's a negative 4 plus 3, which equals a negative 1, just like we thought. So let's plot all of our points and get them on the graph and see what this looks like. So negative 2 and negative 1. Let's see, negative 2, negative 1 would be like right there. Negative 1 and positive 2. So negative 1, positive 2 would be like right there. 0, 3. 0, 3. That's on the line of symmetry. 1, 2. 1, 2. 2, negative 1. 2, negative 1. Ah, there it is. Oh, look at this. So our parabola this time is one of these ones that's pointing in the downwards direction, like this. Got our line of symmetry going right down through the middle, and then there's that vertex. That vertex is happening at 0, 3. We got our label on there. Now, there's one last thing I need to do. Down by the arrow here, I need to write the equation, y equals negative x squared plus 3, and then I'm done. I've got my graph. Again, finding the vertex, doing that first step, helps you set your table up in a way that's the most strategic. If you skip step 1, you can still make a table and plot points, but you might find it a little bit hard to do if the vertex is like way out here at 10 or something. Like it's a little bit challenging. Okay guys, well that's going to wrap up this video, and I'll be posting more on this in the future videos of this unit, but just kind of practice in class, make sure you're making those tables nice and neat, and I will see you in the next video. Bye!